Recursive algorithm. There are 4 parts here. First, review what a function is, and then bring in the recursive algorithm from the function to let everyone understand how recursive works in related applications. Do you remember what a function is? When a function is frequently used in the program, the user can customize the function and call this function when needed, instead of writing all the instructions again, which can simplify the program. There's a sample program on the screen to print out all the elements of the array in B. The function can be used to print the array function. Use the function print to print out all the array elements, and then in main, transfer the array to be printed to the function print. Does this increase the readability of the program a lot? The function format is as shown in the figure above. First, define the type of return value of the function, whether it is an integer, int, or a decimal float, or does not return the value void, etc. They're parameters used by the function in the parentheses, and first define the type of parameter in the same way, then give the parameter a name. Let us try to interpret the example programming code. Here we can see that a function of int type is declared first, the name is example, and the function receive variables of 3 elements, int, bool, and char. Functions can be integrated according to their functions to become a library containing many functions, which can be loaded and used together when needed, such as the most commonly used input scanf and output printf functions are placed in the library of stdio.h. When there is a need to use it, this library must be included. Think about it. Now we need a function for factoring. How can we write it? Find all the factors of integer n. Input description. Each time, one line has only one integer number, which represents the factor of the number to be found. Output description. Each line outputs the factors of the number, and a space separates each factor, and then changes a new line after the output. Here is a program for factoring. In factor, I starts from 1 and searches up. Then use if to find the number whose remainder is 0 after dividing with n. At this time, I is the factor of n. However, is there something missing in the programming code? Take a closer look. What type of data is returned by the factor function? Whether it is necessary to add int or char or any form of declaration. If adding the type of function is necessary, is the function necessary to be modified? In main, a value k is passed in the function factor. There is no declaration in the function, so is the integer k received? This is the correct way of writing. Because the function factor returns a positive integer, so it is necessary to add int in front of it. And an integer k is passed to factor main, so an integer must be declared in parentheses to receive k. Application of function 1, division of 2 numbers. Build a function of the division of 2 numbers for the user to input 2 numbers. After the function is called to execute, output the result of the division of 2 numbers. Please note, if the divisor is equal to 0, will there be a problem? Application of function 2, square root. Build a square root function for the user to input the value n. After the function is called to execute, output the result. Please note, 1. If n is less than or equal to 0, will there be a problem? 2. The received value is calculated to the 3rd decimal place. That is, it needs to be rounded up from the 4th decimal place. Find the narcissistic number. First, we need to understand what is the narcissistic number. The narcissistic number is also known as a pluperfect digital invariant, also called narcissistic number, self-power, Armstrong number, or Armstrong number. The definition of the narcissistic number refers to, this number is used to describe an n-bit non-negative integer. The sum of the nth power of each digit is equal to the number itself. Take 2 as an example. 2 has only 1 digit, and the first power of 2 is equal to itself, so 2 is a narcissistic number. Then look at 153. 153 is a 3-digit number. Let us try to add the 3rd power of each number of 153. The cube of 1 plus the cube of 5 plus the cube of 3 will equal 153 itself. So 153 is also a narcissistic number. Think about how to find the narcissistic number. Build a function to find the narcissistic number. For the user to input the value n. After the function is called to execute, output the narcissistic number that is less than or equal to n. Please note, if n is less than or equal to 0, will there be a problem? Next, let's get into the recursive. What is recursive? Recursive is when calling between functions, whether it calls itself or calls other functions. In the process that it calls itself, this process is called recursive. The function A is that it calls itself, which is directly recursive. The other is that function A calls another function B, and function B will call function A, which is indirectly recursive. So, are there any examples of recursive in life? Deposit compound interest is a classic example of recursive. Do you know what compound interest is? It's what we often call making money with money. Assuming that the original deposit is $1 million and the interest is 20%, the calculation of interest is a function A, which calculates once every year, $1 million at the beginning of the first year. The second year's sum of principal and interest equals 100 plus 20 equals $1.2 million, of which 20 is received by putting 100 into function A. The third year's sum of principal and interest equals 100 plus 20 plus 20 plus 4 equals $1.44 million, of which $40,000 is received by putting $200,000 into function A, and the original principal has to be put into function A one more time, and so on. Function A is called whenever the interest is calculated, and the action of repeatedly calling itself is called recursive. Now, think about it. How to use recursive to practice factorial. What is factorial? A factorial value of n is from 1 times 2 times 3 multiplying all the way to number n. Find the n factorial value of the integer n. Input description. Input one line each time. The line has only one integer number n, which means to find the factorial value of this number. Output description. Each line outputs a number. The number is the calculated factorial value. So when we input 5, the program will help you calculate 1 times 2 times 3 times 4 times 5 is equal to 120. But how to use recursive to practice the n factorial calculation? Think about it. When a1 is 1 and a2 is 2, which is 1 times 2? We can also regard it as 2 multiply a1. Let's keep going. At the time of a3, it is 3 times 2 times 1. Isn't it equal to 3 times a2? Have you found the pattern? It seems like self-multiply the previous number. Self shows up every time. Can it be solved by recursive? Then, at the time of n times n minus 1 times n minus 2, and keep multiplying all the way to 4 times 3 times 2 times 1. That is, n multiplies its previous number, n minus 1. Let's get into the part of programming code. First, we must pay attention to two key points. One, the recursive function must have an endpoint. The endpoint of this problem is to set when n is equal to 1. The recursive function will stop and return the value of the result n. 2. Next, the value of n must be close to the endpoint. What does it mean? Because when the recursive keeps returning, but getting farther and farther away from the end condition, the program is dead. Imagine that your goal is to climb the mountain to reach the peak, but the walking direction you set is going toward a lower place. Of course, you will never reach the peak of the mountain, so the path we set here is call itself again when n is not equal to 1. If it is not equal to 1, it will execute the function n multiplies recursive n minus 1, and continue to call itself until n equals 1, which is the time to reach the peak of the mountain and end the recursive. Application of function 4, reverse output. Please design the display of numbers in reverse order in recursive manner. For the user to input a number n, for example, 854231. After the function is called to execute, output the reverse value of the number n, for example, 132458. Recursive algorithm. Application of recursive function, Fibonacci sequence. Now, let's try the famous Fibonacci sequence. Rabbits never die. This is a story assuming that the rabbits will never die. A farm owner buys a pair of newborn rabbits, A, in early January. The baby rabbits need to be 2 months old to become adult rabbits to produce another pair of baby rabbits. That is, it takes 1 month for baby rabbits to grow up and become adult rabbits. and it takes another month for the adult rabbits to give birth to baby rabbits. So in March, the original rabbit A gave birth to a pair of rabbits B. So there are 2 pairs of rabbits in total. Because rabbits never die, every pair of rabbits older than 2 months can give birth to a pair of little baby rabbits every month. In April, rabbit A gave birth to another pair of rabbits C, and rabbits B are growing up. In May, rabbit A produces another pair of rabbits D, and then rabbits B are also 2 months old and give birth to a pair of rabbits E. So in May, there are 5 pairs of rabbits A, B, C, D, and E. So in October, how many pairs of rabbits does the farm owner have? First, the rows of rabbits giving birth to rabbits must be found in order to know how to use the program to calculate. So let us first list the number of rabbits by month. If we look closely, we can find that when the month N equals 0, of course it is 0 pair. Month N equals 1, 1 pair. Month N equals 2, 1 pair. Month N equals 3, 2 pairs. Is 1 plus 1 of month equals 2. Month N equals 4. Yes, it is 2 plus 1 of month equals 3. Month N equals 5. It is 3 plus 2. Seems like the rule is found. The total number of rabbits will be the total number of rabbits in the previous month plus the number of rabbits that can be born. Let us take a look at the input and output description. Input description. Input 1 line each time. The line has 1 integer number n, which means to list the sequence of this number. Output description. Input a number for each line, representing the nth item in the Fibonacci sequence. Think about it. Should this problem be solved by recursive or by loop? Let us use these 2 methods to practice them and compare and calculate the same items and the time required. The first is the loop solution, the number of pairs of rabbits every month, since it is the sum of the number of pairs of the previous 2 months. So write a loop to let them keep adding. Use a for loop to continuously accumulate before and after. K temporarily store the value of the previous item, S2, and then store the previous item values S1 plus the previous item S2 into S2, and then repeat the process. Can the value of the nth item in the Fibonacci sequence be calculated? Although this problem can be solved using the loop command, it will be easier to solve the problem using the recursive function. The recursive solution is in the function f. When n is less than or equal to 1, then return the initial values 0 and 1. When n is greater than or equal to 2, it will start to add the previous 2 and return it. In this way, return the value of the nth item after repeated recursive. After finishing these 2 recursive examples, what do you think are the advantages and disadvantages of the recursive function? Advantages: make the complicated simple. When complicated problems can be regularized, the recursive function can be used to solve complicated problems, such as taking the n factorial problem as an example. The loop can be used to solve this problem, but recursive will be more suitable. Although there may not be much difference in the small programs, when it comes to large programs, it is very important to reduce the programming code of main and increase readability and logic. Disadvantages: requiring much time and effort, because every time a function is called, it will create the variables declared by the function, which consumes memory resources. When calling itself, it will first use the stacking method to build the variable resources needed by the function. When these variable resources are built and retrieved, additional processing by the CPU is required, which consumes CPU resources, and the execution time will be longer. So, please avoid recursive for the sake of recursive, such as factorial calculation, summing up, arithmetic series calculation, etc. These do not need recursive. There are many applications of the recursive function, such as the Euclidean algorithm, greatest common divisor, Pascal's triangle, Tower of Hanoi, 8 queens puzzle, search and sorting, etc. Let's take a look at some of the applications. Application of recursive function, greatest common divisor. Input description. Input a line each time. There are 2 integer numbers in the line, indicating that the greatest common factor of these 2 integers is to be calculated. Output description. Output a number each line. The number is the greatest common divisor. The concept of Euclidean algorithm used here can be seen from the function GCD. When divisor b is equal to 0, return a, and a is the greatest common divisor. When b is greater than 0, b becomes the dividend. and the divisor becomes the remainder of A and B, continuously repeating recursive. Application of recursive function Tower of Hanoi. There are 3 rods, A, B, and C. There are n disks on rod A, and the size of the disk becomes smaller from bottom to top. It is required to remove all the disks to the C rod according to the following 2 rules. 1. Only 1 disk can be moved at a time. 2. No disk can be placed on top of a disk that is smaller than it. May I ask what the minimal number of moves required to move all the disks to C rod is? If you observe carefully, there's a certain rule in the movement of the Tower of Hanoi puzzle. Repeat this rule to get the minimum number of moves. This process is recursive. Application of recursive function 8 queens puzzle. In chess, the queen can move in any direction and in any number of steps on the checkerboard, and the queen can directly capture the queen. May I ask, if there are 8 queens on an 8x8 checkerboard, and these 8 queens will not capture each other, how many arrangements are there? Think about it. Suppose there's a queen in each row. When a queen is placed on each row, check whether there's a queen on the straight, horizontal, left, and right diagonal of the position. In this way, isn't the action of repeat checking every queen a lot like recursive? Application of recursive function Pascal's triangle. Pascal's triangle is very similar to the Fibonacci sequence, which adds the corresponding upper left corner and the upper right corner together to form a new term. Repeating the recursive of this step will form a Pascal's triangle. Please design the Pascal's triangle with the concept of recursive for the user to input the column value n to be displayed. After the function is called to execute, output the Pascal's triangle of n columns. Please note, if n is less than or equal to 0, will there be a problem? How to avoid it? It is not necessary to handle the arrangement position in the initial stage. After the normal output, please handle the arrangement position. Input description, input 1 line each time. The line has an integer number n, which calculates the Pascal's triangle of n columns. Please note the input of less than or equal to 0. The output is to output the Pascal's triangle of n columns. The number can be output successfully before trying the arrangement. In the input example here, we want to build a Pascal's triangle with 4 rows. The output example will look like this. Think about how to do it. Let us look at this recursive unit now, this problem of calculating factoring. The problem is to find all the factors of the integer n. Input description, input a line each time. The line has only one integer number, which represents the factor to be calculated for that number. Output description, each line outputs the factors of the number, and a space separates each factor, and then changes a new line after the output. This problem is not a recursive problem yet. At present, we are going to review how to use functions. First, let's look at an example of input and output. The part of the input is to input a number 6, and the part of the output outputs 1, 2, 3, 6, which is all the factors of 6. Just output it on the same line. So, how to do this problem? Let us first build the C++ format. Include IOStream using namespace stand. And there's our main programming code area. Return 0. Next, because we want to use a function to solve this problem, we can think about what we need to have a function. Then, this function is responsible for finding the factor, so we name it a factor. Let's think about the parameter and what to put in it later. Now, we are going to write this part of the main program first. Input one line each time. The line has only one integer number. So we first create a number and then input it. Create a k, cnk. After inputting, we will output all the factors of this number. We can handle this part of the processing in the function. That is, we only need to call the function of a factor next, and that's it. But obviously, the parameters in our function cannot be without things, because we want to get different results according to different k's. So, at least one k must be placed here so that the function will know that. What we want to find is the factors of k. So here in our function, we're going to build a parameter, which is an integer parameter, intn. So that we can start writing our function. What should be written in the function? What we want to do is to find the factors. How do we find the factors? We know that the factor is divisible. And the divisible can be processed by the concept that the remainder is equal to 0. So we want to find all the numbers that are less than or equal to n from 1 to n, and that can be divisible by n. It is the factor of n. How do we find it? In this case, you can use it either for or while. Here we will demonstrate the way of using while. Create variable I, which is equal to 1 at first, because we want to find all the factors from 1 to n. As for the part of while, our condition is that I must be less than or equal to n. After n is exceeded, we don't need it. If you want to find the factor of 6, you only need to find the maximum 6. What are we going to do next? In the loop, we just want to see this factor, whether this number can be divisible by n. So, we have to make a conditional judgment to judge whether I is divisible by n. Then we can use n percentage of I when we judge. Use n to calculate the remainder of I, and see if this remainder is equal to 0. If it is 0, it means that I will be divisible by n. Then, since I is divisible by n, it is the number we want. We can output I. Remember that I is the output, not n. After the output is completed, because we need to have a space on the same line, we put a space after I. Regardless of whether we enter this if condition or not, let I run to the next one. Here we need to pay special attention. This I++ will not be in if. Regardless of whether it enters the divisible condition or not, my I always needs to be +1. Like here, 1, 2, 3, 6. When equal to 1, the divisible has output, and then I plus 1 becomes 2. 2 is judged to be divisible and also output. 3 is divisible and also output. The next one, 4, is not divisible. But I still need to add 1 to become 5, so that my loop will continue and will not enter if for the loop to be halted. So remember that I++ should be outside of if. After this is completed, finally, our problem says to change a new line. So output an ENDL. Let's try it and see how it works. Input a number, and we input 6 in the example earlier. Then we can see that it has output successfully. Here you can pay special attention to this. Do you see that there is a space after 6? Because we use numbers with spaces for output. And this is slightly different from our output. There is no space after 6. But in this case, when we submit, it will say that the test is passed. Why? The reason is because in C++, the judgment of data testing it did is only in the situation of one line, and it will judge directly, and the end is the end. No matter what you use to end it, it ends. So it doesn't need to handle this matter especially. Then, of course, you can also handle it. As we know, the factor must always be 1 as in the beginning. So actually, this one is quite easy to handle. We only need to separate the part of 1 to see every factor we'll have. Every number will have this factor of 1. If we take 1 separately, that is, if I equals 1, we only output I at this time. Otherwise, we will output space and I. So let's execute it. Here, there is no space after 6. So it is all right to process it, or it does not matter not to process it, because there is no impact when there is only one line. But if you have more lines, 2 lines, 3 lines, or more output, it must not have spaces after this. This requires special attention. This problem is completed. Everyone can practice and see how to write this problem. Now look at the function of division of 2 numbers in the recursive unit. The problem is to build a division of 2 numbers function for the user. To input 2 numbers after the function is called to execute and output the result. Please note that if the divisor is equal to 0, whether it will cause an error message. How to handle this problem? First, let us process the architecture first. Include I/O stream using namespace stand. Then the main programming code area. Remember to return 0. Next, it wants us to build a function. So we just build a function. But here, we need to pay a little attention because it wants the result of division of 2 numbers. That is to say, if I divide 3 by 2, my result should be 1.5, a case of having a decimal point. So, in the part of function, we should return a decimal point. Then our function should be built to have a decimal point. This float is a floating point number. If there is a decimal point, the result we return may be a floating point number. You can also create the function name at will. The one teacher provided is to use C class. I don't clearly know why C class is used. it may be something for calculation. Then you can also create a name that is more in line with the concept of division of two numbers. For the part of the parameter, because it is division of two numbers, my parameter must have two numbers. We are not sure if these two numbers are integers. And if you set them, if both of them are set to integers, there will be some troublesome situations we can demonstrate first. Of course, because the problem does not specifically require the input of integer, even if the problem is written to the input integer, you may still have to pay attention to some strange situations when you input an integer. Let's demonstrate first, but this is not right. Pay attention to this a little bit. Next, we are going to calculate the result after the division of two numbers. Then, of course, you can directly return a dividend by b. Nothing wrong with it. Anyway, I just want the result after the division of these two numbers and feel nothing wrong with it. We can give it a try and simply make an output. Output this one. Then for my division of two numbers, I just used the 3 divided by 2, just mentioned. Let's execute it. Oh, I forgot the semicolon. This way you will see it shows 1. The main reason is that you set up both of them as integers, and the integer is divided by the integer, and the result returned is still an integer. Then, if you set it as with decimal point, its return will be with decimal, and we have made it with decimal. If you let it be an int here, let's take a look at its situation. It will return to an integer because it will force it back to an integer and then return it back. So here you must pay special attention. Whether it is the type of the foremost of the function or its type in the parameter, you must pay special attention to the decimal result you want in the end. For these 3 things, if you set them to float, it will be better, and it will be easier to get the decimal result you want. Although it is okay to write this way, the teacher has set some variables in the example solution given by the teacher. However, it is a little strange that this variable is set because usually we don't use sum as the result of division. Because sum is usually used for addition operations, we will use the variable sum to process more after adding the sum. Then it is suggested that if you want to set it this way, it may be better to change to A and S. Right. Or if you want to directly return A divided by B, it is all right with the part I just wrote at the beginning. And it is not necessary to set a special variable before doing the return. So the function part of division of two numbers is handled in this way. Next, because we still need to process some information, like here, there should be an error condition if the divisor is equal to 0. For example, if I just let this divisor be 0, an infinite will appear. This INF is infinity, meaning infinite. So when we ask the user to input the main programming code, we may have to do some processing, so we will change it a little bit here. That's because we want to let the user input. That is to say, we set 2 variables for the user to input. And here, because of these prompt texts, because our problem does not have a data test as mentioned before, please input the dividend, and then it will input the dividend. Next, we ask the user to input the divisor. and pay special attention to the divisor cannot be 0. Next, we will let the user input the divisor, and we need to make a judgment on this divisor first. If the divisor is really 0, it means that the user has input a mistake. We will display it to tell the user, your input is wrong. The divisor of C out is 0. It is in a state of input error. If it is not 0, then it means okay, and we can continue processing then. We can do C out here. Then the text here is, as you wish, you can type whatever you want. We will type division of 2 numbers. Which is the same as the function we just built. The function of C class will pass in the dividend and divisor input by our user, and then be changed to a new line. Let's execute it now and see what the result will be. In the same way we just used 3 and 2 earlier, then 3 and 2, we will get the division of 2 numbers 1.5. If we're not using 3 and 2, let's change to 2 and 7. And then it is okay here. It is 0 point something. You can also use the number with decimals. Let's divide 1.5 by 3, so that's okay. Or if you want to use a negative number, there should be no problem, and you will get a negative result. But if your divisor input is 0, it will tell you that the input is wrong. Because if this judgment is not added, it will become the one we just demonstrated, and it will output infinity, the infinite state. But we know that the divisor cannot be 0, so we can directly eliminate it here. To eliminate the condition where the divisor is 0, this is the result of this problem. You can execute it a few more times, and then input more data to see if your output is correct. Give it a try. Let us look at the problem of the square root function in this recursive unit. This problem hopes that we can build a square root function for the user to input the value in. After the function is called to execute output the result, please note, if n is less than or equal to 0, will there be a problem? Then the value calculated, he wants you to precisely calculate the value to the 3rd decimal place. That is, it needs to be rounded up from the 4th decimal place. How to write this problem? For this question, the answer provided by the teacher is a little strange. Let's first take a look at the situation of the answer provided by the teacher. The teacher also specifically noted that this is not precisely calculated. We first paste the numbers provided by the teacher, and then execute it to see what happens. Then we can first take a look at the main program code. There is no problem. That is, first create a number, a variable, and then tell the user to input a positive integer. After inputting, call the function that calculates the square root. Of course, you may use a better name for the function. It does not look good by using k directly, and you can change to a better naming. Then it will call this function, and after executing this very long code, it will output the approximate value after the square root. Let's first take a look at what's wrong with this programming code. First, let's execute it. And see, when I input 2, it shows 1.41. We know that the square root of 2 is 1.414, so it doesn't seem to be a big problem. But why are there only 2 decimals? That's a bit strange here. 1.414. What if it is 3? When it is 3, it shows 1.728. You will feel like something is strange. If you remember the square root of 3, it should be 1.732. If you don't remember, let's use a calculator to see it is 1.732. So, its answer has a problem. Then let's look up some more numbers. When it is 4, it shows 2, no problem here. When it is 5, 2.236. Let's see what the square root of 5 is. 2.2360. So it seems this is quite correct again. Then let us keep looking up. When it is 6, it shows 2.445. But the calculator shows the results of 2.449. So we can find that some answers are strange, and some of the answers seems to be correct. What is it when it is 7? 2.645. It shows 2.645, but the next one is 7. If you round it up, it should be 2.646. When it is 8, the calculator shows 2.828, but here 2.825. So the answer is really strange. Then when it is 9, it shows 3. So there are several answers from 1 to 9 here that are strange. So this piece of programming code actually has an error. But I'm not sure what the teacher meant by this. It is not precisely calculated. But I just want to tell everyone that this piece of programming has some error, and we will find out what the error is later. First, let me tell you, nowadays, point H is rarely used. This kind of point H was used when using C language before to capture some data. In C++, we usually use CMath. When you want to capture the C language-related data, we will start with C and then correspond to that data. Next, let's take a look at the part of this programming code. INTB is the positive integer we put in the main programming code. Then it built 3 numbers here. The I and j here can actually be built in the for loop, because here I and j only live in the for loop. So you can just fill them inside the for loop. It doesn't need to be outside. It might look a little less messy this way. In the outside part, we will create a variable to store the result of the square root in the end. Then here, the teacher likes to use goto. But goto is actually something that breaks the structure of the program a little bit. So, in my opinion, I might prefer to not use goto because, like here, when you see goto, you will have to find where the end2 is after all. It seems a little bit less intuitive. So if you want to change it, here is a suggestion to change it to if greater than or equal to 0. Then we just need to jump to end2 when it is less than or equal to 0. I want to end it directly. Then we can change it to make it greater than or equal to 0, and then I execute it. I just move this part directly here, and I let the middle part be enclosed in if. So I only execute this part of the programming code when b is greater than or equal to 0. In this case, if it is less than 0, I will not execute anything at all, and I will go directly to return 0. The effect is the same as just go to N2. Using this method will make your programming code more readable, because when you see go to, you have to find out where its tag is, which will be a little troublesome. The go to here actually can be changed. I will show how to change it when we reach go to, so let's not touch it yet. Now, let's take a look at what it is doing in these for loops. And we are going to debug in a moment. So we can first see that it makes a equals 0, and then increases a all the way up, and reaches the maximum to b. It is going to see when it will be greater than b. If a is multiplied and equal to b, it will directly go to the end, which means, oh, I found the result of square root. Then I output directly. Here, that's what it means. If it is not equal instead, it is greater than b after multiplying. For example, I want to calculate the square root of 2. Then I start a from 0. And 0 multiplied by 0 is not greater than b. Not equal to b and not greater than b. Okay, b is 2. Pay attention. Then 1 times 1, it is okay because it is not greater than b. When 2 times 2, we will find that 2 times 2 is 4 and not equal to 2, and it is greater than 2. Then at this time, my a will become a minus 1. That is, let a become 1. So in this section, it is looking for the first integer. It is looking for the number before the decimal point. And how big my integer should be before the decimal point. Is this okay? If they are equal, it ends directly. If it is greater than, I will go to the previous one, the one that is not greater than. I will look backward to find what the number next to the decimal point is. Next, the for loop is the part I call it having some problems. First, let's take a look at the 2-layer for loop. One layer is I, and the other layer is j. What are these 2 layers of for loop doing respectively? Here we can see that the teacher uses a POW. And this POW is why we need to include CMath. This POW is stored in CMath, and its purpose is to pick the exponents. Like here, it means 10 to the number of powers. The part of I is from 1 to 3, so here it will be minus 1. The first layer is minus 1, the second layer is minus 2, and the third layer is minus 3. The 10 to the negative power of 1 is the first digit after the decimal point. The 10 to the negative power of 2 is the second digit after the decimal point. And the 10 to the negative power of 3 is the third digit after the decimal point. That is to say, for this part of I, we are doing it to see what the value is after the decimal point is. For the part of j, it uses 1 to 9, so it just wants to judge what the unit digit is after the decimal point. That's where the so-called problem lies. We can see that the teacher used a equal to a plus j multiplied by POW. This section is the biggest problem. Maybe you haven't noticed it. Let's do some situation of Cout to make it easier for everyone to understand. In the outside part, we output the condition of I and A. And in the inside part, we output the condition of J. So that everyone can see what the result will be after this output. When we used 2, which had more problems a while ago. Everyone can see that there seems to be no problem when j is 1. But 1.3 appears when j is 2, and then it directly jumps out of the loop of j, meaning that it thinks that the next one will be more than 2. That 1.3 is not yet exceeded, so it has a display, then the next number. It thinks that after the next number is multiplied, it will exceed 2, okay? But in theory, the next number should be 1.4. 1.4 times 1.4 is still not more than 2, but your programming code thinks that its next number will exceed 2. If you haven't seen the problem, let's continue to look. Here, 1.31, 1.33, 1.36, and then jumps to 1.4. Do you see the problem? At 1, it is 1.31. At 2, it jumps to 1.33. At 3, it jumps to 1.36. At 4, it suddenly carries and becomes 1.4. And then it thinks it is more than b. So it jumps out of j and to the next set. Do you see where the problem is? If not, I'm going to be more detailed like this. The 1 is 1, but for 2, theoretically, we need to find the number 1.32, but it directly drops to 1.33. The reason is that the teacher used j times pow here. And this j will increase from 1, 2, 3, 4, 5 to 6 all the way. So when you use j times pow, you assume now a is 1.3. Then I add j times pow, so I added 0.01, so now a is 1.31. Pay special attention to this. So in the next section, when I add j is 2, so the number I add will become 0.02. So 1.31 adds 0.02. It will become 1.33. When the next run j is 3, I add the number, and it will become 0.03. So 1.33 plus 0.03 will become 1.36. This is why it becomes like this. That's why the answers you calculate are strange. Then to fix it, we will remove j directly. This j does not need to exist. We just go all the way, plus 1, plus 1, plus 1, plus 1, plus 1, and then if you want to subtract, just subtract 1 back. Let's execute it again. Here you will get a more correct result, 1.414. And you will see that every time j is equal to 1, it will go up 1 grid, so that I can successfully judge to 1.4 before jumping to the next one. Then at 1.41, it is successfully judged the 1.41, then jumps to the next one. And then 1.411, 1.412, 1.413, 1.414, then jumps out. This is the result we want. So pay special attention here. Please do not multiply that j randomly. In this way, your increase will become an increase of series and there will be a mistake. So we can come back to see the 3 with errors earlier. Now the answer will become 1.732. It originally seemed to be 1.728. If you forget, I can multiply j back for you to take a look. When it was at 3 just now, you see here, it was a little random jump, because it jumped like this, and its result would be wrong. So pay special attention. Please remove the j here so that our result will be correct. But by simply doing this, it still does not meet the correct requirements of the problem. Because you can see, let's hide these 2 numbers first, mark them off. Like now maybe 2, 3, 5, they all look right. But like the 7 mentioned just now, we still haven't fixed the problem of carrying. For 7, it is 2.4657, but we only display 2.465, so in the current programming code, it can only unconditionally round off but not round up. If you want to round up, it is actually a little troublesome to write the programming code directly. And if you want to round up, you may have to take at least the 4th digit after the decimal point for the part of I. Otherwise, you don't even know which one is the 4th place. Then, of course, you have no way to do the roundup part. So at least we have to take the 4th place after the decimal point before it is possible to round up. And how do we round up? It is actually a little troublesome to write the programming code directly, but we can use the built-in to control the number of decimal places. So let's include the necessary things first. There will be a part to control the number of decimal places to set the precision value. We set the precision value to 3, then this 3 will control the entire number. If we want to control only the decimal point, we need to add a fixed in front of it, which can help us control the number of digits simply after the decimal point. You can see here just now this calculation result was 2.6457. Then, after I do the control of after the decimal point, it becomes 2.646. For the others, you can also see that it will help you display 3 decimal places. You can test some numbers to see if your programming code is correct. Here it carries 3.3166, so it will help you carry. If there is no carry, it will not help you to add 1, such as 1.414. Since it does not need to carry, so it will not make changes. Here is the 4th place is 2, it will not make a change. So if you want to display 3 digits after the decimal point, remember the first thing you have to calculate to the 4th digit after the decimal point before you can do the roundup. Then the second thing is that J, please remove it. That J will cause an error in your calculation. And this goto just mentioned because I don't like to use goto myself. So it doesn't matter if you break it directly here. Break it directly here, and its situation will be the same. That is, the result of execution will be the same. However, if you simply do the break, its efficiency will be slightly lower because you only jump out of the loop instead of the entire loop. You only jump out of the loop closer to you, and you do not jump out of the outer layer. So if you really want to break the entire 2 loops, you might just have to set it up and use flag to do the settings. When you're in the loop, you may be able to set a flag to make it equal to false or equal to 0. If you're here, it may have to be flag. And the situation is that you will only execute when it is true. Enclose it this way when you break it. It will be able to jump out direct. Of course, when your flag is in the outer layer, you have to give it an initial value first. And you can process it in such situations. Remember the semicolon. I actually forget to put a semicolon quite often. Well, there's one more. Oh, okay. I forgot to set its type Boolean. So in this way, your situation will be the same, but its efficiency will be better than just writing the flag, because it will at least jump out of both layers. Okay? In this way, it is a result written for this problem. But for this problem, if you have already used math, and then use a precision value of this setting, you can actually use POW to find the result of square root directly. Then this function is not necessary. You can just output directly. Let's copy this section. It doesn't matter if you don't want to run the function at all. You just directly output POW A, and then it does square root, which is 0.5. We cannot use A. Instead, let's use B here, because what I input was B, so POW B, and then 0.5. Then when you input it, we'll give the correct result. So writing the function for this problem is to practice the function. And then how do you capture the number 1 by 1? To the first, second, and third place after the decimal point 1 by 1. Then, if you just simply want to calculate the square root, you can use the function of POW to process B and 0.5 directly. Is this okay this way? So, remember to work on this section of the programming code. Otherwise, the result will be wrong. So please practice it. Let us look at the problem of narcissistic number function in the recursive unit. The problem is to create a function to find the narcissistic number. For the user to input the in value, after the function is called to execute, output the narcissistic number that is less than or equal to n. Please note that if n is less than or equal to 0, will there be a problem? Let's take a look first. What is a narcissistic number? The text description of narcissistic number is a bit long. Here it says that there is a natural number n, where d represents the number of each unit's digital in the natural number. Here, a equals dk and dk minus 1 all the way to d1. In other words, if you have a number that may be called 1, 2, 3, 4, then the so-called dk will be our 1, and then dk minus 1 will be 2. So it is actually d4 equals 1, d3 equals 2, d2 equals 3, d1 equals 1, O equals 4, 1, 2, 3, 4. The first one is d4, d3, d2, d1. Then this n will be d4 times 10 to the power of k minus 1. It will be 1,000. Then 234. So add them up will be our n. So here it is just describing the meaning of each unit's digit. Then if it satisfies this condition, it means that for every number, it will do the power of k for every number. After it does the power of k for every number, the result will be the same as the original number. Like here, its power of k means to the power of 4. 4 digits means to the power of 4. 3 digits will be the power of 3. 2 digits is to the power of 2, and 1 digit is to the power of 1. Then if the result of this will be exactly equal to meaning after they're added, it will be exactly equal to your original number. If you add these 4 numbers to exactly equal 1, 2, 3, 4, it will be a narcissistic number. Then we can look at the condition of the number that is really equal to the narcissistic number. Like the 153 provided here, it will be 1 to the power of 3. add 5 to the power of 3, and then add 3 to the power of 3. That is 1, and then add 1 to 5, and then add 9. No, it is 27. Calculate it wrong. 1 plus 125 plus 27. Then the result here will be 153 exactly. So this 153 will be a narcissistic number. Is that okay? Let's take the answer provided by the teacher. In fact, the teacher only hopes that the students can calculate the 3-digit number situation with the material provided. He didn't ask too much for the others. Then, if the students want to calculate that is a more expanded situation, it's okay too. Let's first focus on 3-digit numbers. That is the answer provided by the teacher. Although this answer does not seem to have the same meaning as the problem, let's look at the answer provided by the teacher first and what it will be like. So in the same way, let's build our structure first. As for the main programming code area, we will have the input number. So I'm not sure why the teacher likes to input I, but I personally, it's better to input N, because I and J are usually used in 4. But the teacher used I and J, but I think that the input N would be a little bit better. Then the teacher used go to, which he likes very much. So he will have an RE, which is a label to be used for go to later. Then I will demonstrate another way of writing, which is how to write without using go to. Next, give the user a prompt text. That is, the teacher only wants to handle the 3-digit number situation. And he hopes that the user will enter a positive integer of 3-digit number. And then he will input a number. Based on whether this number is between 3 digits, if it is less than 100, or it is greater than 1,000, and greater than or equal to 1,000, it means that it is not a 3-digit number. In this part, the teacher just let the user only can input a 3-digit number. Although it does not meet the requirements of the problem, we can try this version first. Then here is the use of go to, which the teacher likes to use. It means that if the input is out of range, he will let the user to re-input. If it is not out of range, he will output his narcissistic number. Because the problem is to output the narcissistic number less than or equal to n, it will output several of them. So in this case, it processes with a loop. Because the teacher only processes the 3-digit number, his I starts from 1, and then it is less than or equal to the number you input. Next, I++, call the function in it that he uses to calculate the narcissistic number. Of course, you don't have to use k. Only using k is not too good. Okay, then we will create this function. In this part, because the teacher only focuses on the 3-digit number, So here, he directly divides the 3-digit number into A, B, and C. The part of A it is. If my 3-digit number is like the one earlier, 153, then A will be this 1, the one you want to capture. B is to capture this 5, and C is to capture this 3. So if we divide D by 100, we can capture the 1. For the part of B, we must first take the remainder of D from 100 to become 53. Then divide it by 10 so that we can capture the 5. For the part of C, you can also let it do %10 and then divide by 1. However, after %10, divide by 1 has no effect. Just do %10 directly is fine. In this way, we can turn A, B, and C into hundreds digits, tens digit, units digit. After these numbers are captured, we can judge their exponents and what the result is after their power of 3. Then if we want to use POW, we must remember to include CMath. And add up the third power of A, B, and C. After adding up these numbers, if it is equal to D, we can be sure that it is a narcissistic number. So at this time, we can output this number and call it a narcissistic number. Then let's take a look at the result of this programming code execution. Okay, I forgot to type the semicolon again. Here we go. We also need to input a 3-digit number. Let's input 200. It will display the narcissistic numbers that are less than 200, but actually this section of programming code does not show all narcissistic numbers that are really less than 200. After all, 1, 2, 3, 4, 5, 6, 7, 8, 9 is actually the narcissistic numbers because the 1 to the power of 1 is 1 and 2 to the power of 1 is also 2, so they're also the narcissistic numbers. However, the writing provided by the teacher here is that he only cares about things in the 3-digit number, so you can also try to change it yourself later and expand it to the real meaning the problem wants. Okay. Let me first talk about how to process the goto of this RE. If you don't like to use goto like me, we can use while instead. Because its effect is actually just to allow the user to re-input when the input is wrong. So I use a while. It can keep repeating. Then, if it is right, it will leave this loop, so that's it. You can give it a try. Its effect is actually just hope for the range of wrong output. We will allow the user to re-input, then for the range of correct input, I will end. So you can also use while and break together so goto can be removed. Okay, then everyone can give it a try. And if you're interested, you can think about it again. If you want to expand to a general version, that is the problem, is actually output, the condition of less than in how to process it. Now, let's give it a try and see how to actually write the programming code required by the problem. Instead of just looking at the part of a 3-digit number. So let's change the statement here first. We can let it input a positive integer, but in fact input 0 is fine too. But a negative 1 is not okay. So here, if it is less than 0, give it a prompt not to enter less than 0. Then it can repeat the input. In this case, we are going to start from 0. But because we need to know what digit number it is now, for us to know by how many power to multiply, such as the one-digit number is to the power of 1, a two-digit number is to the power of 2, a three-digit number is to the power of 3, and a four-digit number is to the power of 4. So try to process power directly on the outside, and there is no need to process power on the inside, which may be better. Then let's build it to help us calculate. In this case, I will use a code that can calculate the length of variable. And I want to know the length of the number. So when the length may increase, I will make it plus equals 1 like this. But how do I know that its number of digits has increased? For example, my I starts from 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 are all single digit. When it reaches 10, it will become a two-digit number. When it reaches 100, it will become a three-digit number. And it becomes a four-digit number when it reaches 1,000. So here I set another variable, which is related to the power of 10, which is 10 at the beginning. Here I will check the I. If it is greater than or equal to the power of 10, I know that it has crossed 10 now, which means its number of digits has increased. At this time, I can add 1 to my calculation of the length of the number. Then every time it crosses over, I can make it multiply by 10 and multiply by 10 again. That it is 10 at the beginning, and after crossing 10 with this power of 10, I will make it become 100. After crossing 100 with the power of 10, I will make it become 1,000. In this way, I can calculate the length of the number, that is the number of digits. So I also pass this len into our function. So we need to change the function a little bit. That's because I don't want to set ABCD anymore, so I use num to express this number, and I use len to express the length, the first three letters of length. Then the ABCD here is not what I want, because I don't know how many digits I have now, so we will use the for loop to process. In this case, I can first create a variable total to help me calculate the result after adding those powers. So I will build a for loop and let it run for me for I equals 0. I is smaller than our len I++. I'll run it once for one digit, twice for two digits, and three times for three digits. Every time I run, I can capture it directly. It is better to start capturing from the units digit, 10 digits, 100 digits. Then the situation I want to capture is that it may be this num. This number, something after the percentage of 10, this will be a units digit. I let the total plus be equal to this units digit, and then let this num be divided by 10. In this case, for the originally 153, and I captured the 3 and added it to the total, then the 153 is divided by 10. The quotient will be 15, so now the number will only be 15. So the next time when I capture its units digit, it will be 5, and after capturing 5, it will be divided by 10, and it will be only 1. So the next time when I capture the units digit will be 1. Then I will compare whether the total is the same as the num. So let's try to see what the execution result will be now. Now you can see that it only displays 0 as the narcissistic number, but in fact, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 should all be narcissistic numbers, which means that there is an error. Here, we can think about where the error is in this section of the programming code. The error is just here. Let's take a look and figure out where the error is. Have you figured it out? I'm going to tell you now. Here you can see that we judge whether total and num are equal in the end. But for the num, here we actually made changes to the num. So after the num is actually processed in this way, The num still becomes 0 no matter what. In other words, we need to create another variable to be the same as num. And then when processing in it, it is always processing this number, this num1. It doesn't matter if num1 is finally down to 0. Anyway, our original num is still there. In this way, when we execute, its results will be more correct. So 100 looks like this. Then let's take a look at 200. For 200, it ranges from 0 to 9. But don't know why our 153 is not displayed. We can check again to see where it is a bit strange. In this case, we can look back to see if there's something wrong with our writing. We can try to do the output. Let's output I and the length to see if there are any errors in our length and I. It seems that the length does not have an error, so the error should not be here. Let's take a look at the inside part. Let's take a look at this total. And how is the condition of the num? We can see that our total is only 9 at 153. This thing is a bit strange. Why is it only 9? In theory, it should be 1. 153. 1 to the power of 3 times 5 to the power of 3 times 3 to the power of 3, but it only has 9, which is 1 plus 5 plus 3, so we can find out. Oh, so we forgot to power. So here, we just make it do the power. If it is to the number of power, it is processed according to its length. So let's execute it again and see. For the part of 200, 153 appears. Then if we enter 2000, there will be a 3-digit part just now, and then a 4-digit part will appear. Then if I enter 20,000, I can see that it has more part of the narcissistic number. In this case, here it is really what this problem wants: input a number, and all narcissistic numbers smaller than this number will be displayed. Everyone can give it a try. Let us take a look at the problem of n factorial calculation function in the recursive unit. Build an n factorial calculation function for the user to input n value. After the function is called to execute, please note if n is less than or equal to 0, will there be a problem? For this problem, you can see that there is nothing in our input example. In other words, this problem does not have any data test, and you will pass whatever you submit. Later, I will talk about why there is no data test in the next problems. First, let us think about how to do this problem. What we want us to do in this problem is to build a function, which can be used to calculate n factorial. But here, it is not asking everyone to use recursive. Let's just simply practice the functions first. In the same way, let's process the format first. Include IOStream using namespace stand. Then the main programming code area. Remember to return 0. Then we want to have a function. So we definitely need to build a function in a moment. You can name the function as you like. The name provided by the teacher uses C-class, which probably means a calculation. There is no clear principle in the teacher's naming. Next, in the part of parameter, the teacher used an INTA. That is, when we calculate the n factorial, we will definitely need to have a parameter according to the difference of n, and then do the process, so we must have at least one parameter, so that we can calculate different results based on the difference of this parameter. The int used in the front means that we will return an integer in a moment. Next, what are we going to do? We can think about it first. Do you need to write the main programming code area first or write the function first? Both are all right. Then, let's write the function first. For the part of the function, we need to calculate n factorial. That is, when you enter 5, I want to calculate 5 times 4 times 3 times 2 times 1. See what the answer is, and return this answer, which is what we are going to do. We want to do it in this C class. So, where will 5 come from? 5 will be this parameter a, and 5 is from this parameter a. If we want to calculate 5 factorial, then this a will be 5. If we want to calculate 10 factorial, and then this a will be 10. The calculation we want to do is to multiply from 5 to 1. You can also think reversely multiplying from 1 to 5, which is with rules, so we can use the for loop to process. Put a number, a variable, in the for loop. From the beginning, let it be less than or equal to a. Remember to have an equal sign because I want to go from 1 to 5. If a is 5, I need it to be equal to a. Only less than is not enough. Next is k++. And we need to do a continuous multiplication in it. So we need a variable to store the result of the continuous multiplication. And the teacher setup is sum here, although it means addition. Let's just do it that way. Of course, you can also think of it as a sum. That's fine too. So with this sum, we are going to let it continuously multiply. Then pay special attention to its initial value. You should set it to 1 instead of 0. After all, if your initial value is set to 0, it will be 0 no matter what it multiplies. This will not achieve the effect we want. So we have to use the initial unit element of the multiplication, which is 1, to do the calculation. Then every time we multiply it is the current value of sum. And then multiply it by k, and k will slowly change from 1 to 2 to 3 to 4 to 5. At the beginning, the sum is 1, then we will get 1 times 1. So now the sum is still 1, but k becomes 2, so it becomes 1 times 2. Now the sum is 2, then k becomes 3, which is 2 times 3. The sum becomes 6, and k becomes 4. It will be 6 times 4. The sum becomes 24, and k is 5, so it becomes 120. This is the result we want. Put in 5, and I will end up with the answer of 120. So this sum is the part we want to return. Is that okay? This is the function we want to calculate in factorial. But here we are directly using the method of loop for process, and we haven't used recursive yet. Next, we are going to do the part of the main programming code. The main programming code area the teacher gives, hoping to give the user some prompt texts. And these prompt texts are the reason why this problem does not have a data test. To start with, we will enter a prompt text, "Please input a positive integer." Next, we want to input a number. And which number do we use? We first create a variable and then do the input. After the input, because the problem said to pay attention when it is less than or equal to 0, will there be a problem? Here the variable setting is a bit strange, but it doesn't matter if you set I or N. Next, we are going to judge whether this variable you input is less than or equal to 0. Because if it is less than or equal to 0, it will have a slightly strange situation. We will display that it outputs input error. Because we want the user to input a positive integer, but he entered a number less than or equal to 0, then we know that the part of less than 0, the factorial, cannot be calculated. Of course, equal to 0 is okay, but we want the user to input a positive integer, so we directly show him input error. In other situations, we will actually calculate its factorial. In this case, we can output like this. The I factorial is the result of calculating I with this factorial function, and then changing a new line. Let us first see the result after it is executed. So it will first input a string of texts to prompt the user to input a positive integer. Then if the input is incorrect, it will display the input error. Then if I input correct, it will tell me the fifth factorial is equal to 120. You can try a few more cases to determine whether there is an error in your programming code. If it is 3, it should be 3 times 2 times 1. It will be 6. So when it is 3, it outputs the third factorial is equal to 6, so this is okay. So why is there no data test in this problem? Mainly because of the prompt text like this. It just needs to be written in your data test. For example, if we look at the previous problem with data test, before you input k, if you actually give it a prompt text, the problem just submitted will pass, and it has the condition of meeting the data test. But if you input a prompt text in this way, it will think that your output is with this extra string of text, and it does not match our test data, and then it will display an error. And for this problem, the teacher probably hopes, the teacher's original intention should be that you can practice this kind of exceptional situation and then display. So we don't have to test data for this problem. You can execute it more to see if there are any errors in your programming code. Like 7 factorial, it should be 5040. You can see if your programming code is correct. Then enter a negative or a 0 to display the input error. It will be fine this way. This is the part of the n factorial calculation of this problem. Then the following problems do not have data test either, so you need to do more executions and then judge whether this part of your programming code has an error or refer to the answer, or watch this part of the video to see if there is an error. Okay, this is it. Everyone can do some exercises. Let us look at the reverse order display in this recursive unit. In the reverse order, it just reverses the order of the numbers. So in here, it hopes everyone to use the recursive method to display the numbers in reverse order. Then the user will input a number, for example, 854231. Then the way he wants to appear his reverse order becomes 132458. That is to output in reverse order. Then how to write this problem? In the same way, we first write the architecture. Include I/O stream, using namespace stand, and then the main programming code, return 0. Then we let the user input. For the input here, we may just let the user input a number in. But you can give the user a prompt before inputting. Of course, if there is a data test, don't give the prompt text. It will cause an error condition. But the problems do not have data tests now, so the prompt text can be given at will. Next, you can also do some processing based on his input. Because if we want to display the numbers in reverse order, we want his input to be a positive integer. He inputs -1, we will have a little trouble. First, based on his input, if it is -1, you can make it an error condition. Equal to 0 is actually okay. It depends on whether you want to process it or not. Equal to 0 is actually okay. Then, if you don't even want to process 0, just process it together. Anyway, here we're going to input a positive integer. Okay, output may be input format error, etc. If there is no error, you can let him do the execution. For the output part, we can let it show what you just input first. This is very much as you wish. You can type whatever you want. Display what was just inputted and see what the reverse order display will be. The reverse order numbers. And the output here will be processed in the function. Of course, it is your function, so don't have to name it K. You can think of a better naming. For the answer provided by the teacher, he still let you do repeated input. So as mentioned earlier, the way of writing goto. With the writing of goto, you can allow the user to re-input if the input was with error. Of course, you don't have to use goto, because goto is still structurally destructive. So you may use while true to let it repeat the execution. And then until it inputs correctly, then break it after the result is output. No more while true. Here, it depends on the writing of Go-To you want to use to allow the user to re-input or not use the writing of break. Both are fine. Next, let's write this function. How do we reverse the numbers to output? In this case, we will directly output in the function. So you can actually use void in this function. Because we don't need to return anything, you can use void. Then here we put a parameter. Then we will see what it will become after being reversed. We can use a variable to store what exactly I want to output. Or you don't have to. I think this is okay. Then what we want to output is 854231. I want to output 1, then 3, then 2, then 4, then 5, and then 8. So every time I output is to output the units digit, so it is in percentage of 10. This is what I want to output, the units digit. Then don't change new line and no space, none of these. No new line and no space. Next is this in after I output 1. You can change it into only 85423. The next time I do output, it will output the units digit. So this in, I let it become the result of the quotient after being divided by 10. Then, as long as it has not reached 0, as long as it is not equal to 0, I will continue the call. So after 854231 starts to output 1, it becomes 85423, which is not 0 yet, so call again. After 85423 outputs 3, it becomes 8542, not 0 yet, continue. 8542 outputs 2, it becomes 854, continue. 854 outputs 4, it becomes 85. Then 85 outputs 5, it becomes 8, continue the same way. After 8 outputs 8 here, n is 8. 8 is divided by 10, its quotient will only be 0. If it is 0, we will end. So this is how we display it in reverse order. Then let's execute it and see. Then it shows us there is a mistake. Let's see where the mistake is. Wow, this message is so long. Okay, it doesn't want me to use void. It doesn't matter. Let's keep it this way. It's okay not to return anyway. Here, it will tell me that its reverse order is 0. That is because we want to use int here. It will return a reverse order to show. So in this case, we may have to modify the part of the main programming code a little. I use void here. So we don't want it to be with cout in the main programming code area because you can see that 4321 appears here, this one. The front of the number in reverse order appears, and that is the entire cout. It will not output what's in the front, it will read the entire line. Then after that, there is a K. Over there, it will enter K to run and output the entire line after the run is done. So let's write this one in the back and try again. This is the result we want. Then after you're done with input, you can change a new line that is okay too. In this way, it is okay whether there is a new line or not. It is at the end anyway. The earlier 854231, into this it will be 132458. Then you can test a few more sets of numbers to see if there's any problem with your programming code. Just type in the number to see if it reversed. Wow, what did I type? I typed something very symmetrical, so it doesn't seem to be very effective. You can type something that is not symmetrical and may have a better effect. In this way, you will see more clearly that it is displayed in reverse order. Is this problem okay? You can think about it. You can think about why its reversed order display will be output like this. We just output the units digit first, and then delete that units digit and turn it into a smaller number. Call our function before it reaches 0. Repeat the call and output one result every time, and that's it. Hurry up and give it a try how to write this problem. Now, look at the problem of Fibonacci sequence in this unit of recursive. And for this problem, I hope that everyone can use recursive to solve it. Do you know what the Fibonacci sequence is? Let's take a look at the description of the problem. The problem says there is a function when n is equal to 0 or 1. F of n will be equal to n. When n is greater than or equal to 2, f of n will be equal to f of n minus 1 plus f of n minus 2. What does it mean? Let's take a practical look. Let's write a few situations first. When it is 0, when it is f of 0, it will be f of n equals n, which is 0. When it is 1, the same as f of n equals n, so it will be 1. When it is 2, it will add the previous 2, so when it is 2, it will be 2. The same is true for 3. F of 3 will be equal to f of 2 plus f of 1, so it will be 2 plus 1. Ah, I wrote it wrong. When it is 2, the previous 2 are added together. So when it is 2, it will be 1 plus 0 and just 1. And when it is 3, it is the same to add the previous 2, so it is 2. As for 4, it is the same to add the previous 2, so it will be 3. When it is 5, 3 plus 2, add the previous 2, it will be 5. And when it is 6, add the previous 2 to be 8. When it is 7, it will be 13. So the rate of its increase will be faster and faster. When it is 8, it will be 21. Furthermore, it will continue to expand and expand, and the rate of its increase will be faster and faster. The line on the back, it is the Fibonacci sequence. This sequence of 0, 1, 1, 2, 3, 5, 8, 13, 21 is the so-called Fibonacci sequence. So, how do we use programs to write the Fibonacci sequence? Let us first look at the input and output. For the input, it inputs one line each time. The line has an integer n, which represents the Fibonacci sequence we want to list. For the output, it output a number, representing the nth term of the Fibonacci sequence. The example here is exactly 5 and 5 as we wrote here. The fifth Fibonacci number will be 5. So when you input 8, 21 should appear. When you enter 6, it will be 8. And input 0 will be 0 input, 1 will be 1. This is the situation we want. Next, let us think about how to write the programming code. First, write the structure. first include IOStream using namespace stand, and then the main programming code area. Remember to return 0. Next, we just think about our function, how to write this recursive function. Let's just follow the writing of the problem. The problem says that there is a function f and the parameter will be an int n. Next in this function, we will find out when n equals 0 and n equals 1. We need to do return. F of n is n, so we need to return n. When n is greater or equal to 2, we need to return f of n minus 1 plus f of n minus 2. So what should we do? For this problem, unless you input a negative number, otherwise for this problem, when you enter 0, 1, or something greater than 2, if you enter 2, it is 1 and 0, so it is 1 and 0. Then input 1 will return n, and input 0 also return n. So the situation we need to deal with is that when n is less than or equal to 1, which is the situation of 0 and 1, you can write less than or equal to 1. Or n equals 0, or n equals 1. All can be written this way. We write less than or equal to 1 here. When less than or equal to 1, we return n. No matter if it is 0 or 1, we always return n, because we return 0 when n equals 0, and we return 1 when n equals 1. Next, in other situations, we need to do a recursive relation. If you know the recursive relation in the recursion, this problem is very easy to write. We just write according to this recursive relation. So, it is either less than or equal to 1 or greater than or equal to 2, otherwise the part is to process greater than or equal to 2. When greater than or equal to 2, our f of n will return the condition of n, f of n minus 1 plus f of n minus 2. This completes our recursive relation. Isn't it simple? We just return the addition of the previous two numbers of n. And in the situation of n is small enough, we will let the computer know the answer directly. So when it is 0 or 1, it is small enough. That is the initial value of our recursion. And we directly let the computer know that when n equals 0, we return 0. When n equals 1, we return 1. In other situations, we just return the addition of the previous two numbers to complete the recursive part of the Fibonacci sequence. What should be written in the area of the main programming code? Similarly, we need to input an integer, so we first set an integer in, and then input it. After the input, we are going to call f of n. Let's execute it and see. You can see here, it did not do any output. We can execute it again. In theory, when it is 8, it should show 21, but it did not output. This is what we have mentioned before. In the recursive, we cannot directly output. So you need to write the part of output in the main programming code area. Here, we are going to see out f of n. When you write it this way, it will give you the real output. Let's take a look at the others. When 8, it is 21. Then see if the boundary 0 or 1 is correct. It is 0 when it is 0, and it is 1 when it is 1, which is great. When it is 2, it is also 1, and when it is 3, let's see if it is 2. It's also 2, very good, so there should not be any problems with this one. Let's submit it to see, and the test is passed. This is a classic problem in recursive, the Fibonacci sequence. Everyone can try to find out how to solve the problem of the Fibonacci sequence. Let us look at the problem of Fibonacci sequence in the recursive. For this problem, I hope everyone uses the loop method to design the Fibonacci sequence instead of the recursive method. Pay special attention here. The user inputs the number n of the Fibonacci number he wants to display, and then you can output the nth Fibonacci number. Then please try to compare with the recursive method and see which method you find easier and which method is more effective. Then let us write the Fibonacci sequence in the form of a loop. Do you still remember what the Fibonacci sequence is? That is when we add the previous two numbers. It is equal to the value of the latter one. Start with 0, 1, then add the previous two numbers. Add them, then add the sequence that appears in this way. It is the Fibonacci sequence. So, let's write the format first. Using namespace, stand, and then the main programming code. Okay, the format is done, and then we are going to calculate the Fibonacci number. In this case, we must first have a variable to capture the user's input. The user inputs which number of Fibonacci numbers he wants. We will help him display it. What's next? Next, we are going to repetitively calculate the previous two numbers, adding and keep adding until the nth Fibonacci number. So here, we can use the for loop method for I equals 0, I lesser than n. I++ to find our nth Fibonacci number. Then for the nth Fibonacci number, how do we save it? We just want to calculate the results of the previous two numbers. So we can use the previous two numbers and set two variables to put them in. The previous two numbers, S1 and S2, to store them separately. Well, at the very beginning, S1 and S2 have values. At the very beginning, they are 0 and 1. Next, we just add them, adding, and where do we want to keep adding? Here, we just have to think about this. Where do we want to keep adding? And how to process it. To start with, we can first set up a variable. This variable is used to store our value because if we simply move it, like what we want to do for S1 to let it become S2, then we hope that S2 will become the result after the addition. But if I write it this way directly, it will become S1 becomes S2, and then S2 becomes S1 plus S2, because S1 has been changed just now. But even if you change their positions, it won't work, because S2 has been changed, so S1 equals S2, it still has no effect. At this time, use a variable to store S2 first, and then after S2 is changed, and then set S1 equal to the K. Then the number of S2 can be captured. After repeating this process and finally outputting S1, we will get the condition of the Fibonacci number we want. We can execute it and see. So the fifth Fibonacci number is 5, and the eighth Fibonacci number is 21, which is what we want. Is this okay? So how does it compare with recursive? We wrote recursive earlier. We can try to make a brief comparison first. We input a relatively large number to see its result. First, it will tell you that too many resources are used. Then we input a smaller number, 100, to see if 100 can get the result. It does not seem to work either. Then we input a smaller one, 50. But it also does not work. Then 30. 30 works pretty quick. Then we add a little bit more, 40. 40 is good. It takes a bit longer. Then 44. We can see that it doesn't work again. Let's go back here and give it a try. 44 works successfully. 50 exceeded the number range. So here we may be able to set it slightly bigger and set a long int. Then 50 will work successfully. If it is a little bigger, it will also work. So we can see that if the Fibonacci sequence is processed in a simple loop, his efficiency will be better. Then you can use the recursive method, the recursive method we just used. It will take a little longer, so if the input number is slightly bigger, it will not work too well. But the advantage of writing with recursive method is that you can write it successfully by looking at this recursive formula. If you read this here, you might not understand what it is doing. Allow S1 to become S2 and S2 to become S1 plus S2 and then output S1. Maybe you don't really understand what it is doing. So, to make it easier to understand, it may use the recursive method. And it will look exactly the same as its recursive formula, but using the loop method, it will be slightly more efficient. So, if you want efficiency, you may use the loop method. If you want the programming code to look more like your rules, you can use the recursive method to process it. Here, let's think about it. And let everyone try it out here, and then think about the difference between these two methods. Now, look at the calculation of n factorial in this recursive unit. And I hope everyone can use recursive to work on this problem. Although it is not a particularly good way to use recursive when calculating the factorial, when practicing recursive in the beginning, it is a relatively simple and understandable form of recursive. Then let's try to use recursive for factorial calculation. Remember what factorial is? Factorial is what we would use an exclamation mark to denote in mathematics. The 5 factorial means that starting from 5, multiplying all the way to 1. So 5 factorial will be 120. Here you can see our input and output. At 5, it will output 120. This is the meaning of factorial. Let's take a look at what the problem is asking. The problem wants us to calculate the n factorial value of the integer n. The input and output parts are also very simple. Input one line every time, and the line has only an integer number n, representing the factorial value of this number we want to calculate. For the output, it is to output the factorial value of this number. So when you input 5, you will get 120. When you input 4, you will get the result of 4 times 3 times 2 times 1, which is 24. This is the input and output we want. So how do we do this problem? In the same way, let us first process the C++ format. Include IOStream using namespace stand. And then write it in the area of the main programming code. Return 0. Next, we will process the input and our recursive. Then this problem hopes to use recursive, so we must have a function. And this function is to return the recursive value. So we can make it an int function. Then, for the name of our function, we will use the English of recursive to help you all know more about the English word recursive and how to spell recursive. Then, think about the parameters inside later and what to put in our function. Next, let us first write the area of the main programming code. For the main programming code, we need to input an integer number n. So we first create an integer n, and then input this in. The next step is to call recursive. And here, because we want to return an integer, we use the output method in the main programming code area. I'll talk more about it later. What is the difference between just calling the function and using output function? We can have a look later. It is also obvious that we should put a parameter in the function. In this way, the program will know that we are doing the call of functions in. We want to get different results based on the difference of n. And what exactly are we going to do with this recursive function? First, we write the parameters it needs an integer parameter. We use the lowercase n to represent it. And for this recursive function, what we want to do is the calculation of n factorial. So, when my function enters 5, recursive, if I enter 5. In the recursive, we want to break down the problem smaller, then smaller to the point where you can process it. So, when you enter 5, we can break it down into smaller problems. It is difficult for you to calculate 5 factorial, so we will treat it the problem as 5 times 4 factorial. Then, if the 4 factorial is still difficult to calculate, we will break it down a bit smaller. Just leave the 5 alone. Then for the part of 4 factorial, we just break it down to the problem of 4 times 3 factorial. Just keep breaking it down until you think your problem is small enough that you can handle it. We will then process it. I'll write it down so it's easier to understand. So next, we continue to break it down. Keep the 5 times 4 earlier. For the part of recursive 3, we just break it into 3 times 3 factorial. 3 times 2 factorial. Then continue to break it down. 5 times 4 times 3 are all kept. And then the part of the second factorial is broken down 2 times 1 factorial. Here, we have a small enough problem. Factorial. 1 factorial is very simple. 1 factorial is 1. So, this is what we call a small enough problem. We know 1 factorial, it must be 1. We just need to return 1 here, and return is 1. And we know that 1 factorial is 1. So 2 factorial is 2 times 1, the answer is 2. And 3 factorial is 3 times 2, the answer is 6. And 4 factorial is 4 times 6, the answer is 24. So in the end, the return of 5 factorial is 5 times 24, which is 120. This is the part of recursive. So how do we write this into a programming code? We know that we want every one of these to be written as n times its previous recursive n minus 1. If it is recursive 5, I want it to be 5 times recursive 4. That is n times n minus 1. Then recursive 4 will be 4 times recursive 3. So it is also the same as the part of n times n minus 1. This is our most important part of recursive. Then we need to have one more thing, the so-called stop condition. That is the problem that we break down to the smallest, and we directly give the computer the answer to this problem. In this way, the computer will know when to stop and return. So when n is equal to 1, we have to tell the computer to stop. Here we can return. You can return 1, or you can return n. Both are okay, because now n is equal to 1. If it is not, we are going to return the case we just wrote n times recursive n minus 1. You can write them at the back of the if, or you can change a new line. It's up to you. Then we will demonstrate the rare case of writing directly at the back. For this function, it is n enters like when 5 enters, isn't it equal to 1? So I will return this part of n times recursive n minus 1. In this case, if we encounter recursive 4, I will let 4 enter, and then enter the part where n times n minus 1, which is 4 times recursive 3. Run all the way until it shows up 2 times recursive 1. Then this recursive 1, I will enter and get the return in. So the part here will become 5 times 4 times 3 times 2 times 1. After returning 1 and then slowly returning back, we know that recursive 5 is 120. Then let's mark off this section. And let's execute it. Input 5, and we will output 120. And as just mentioned, let's take a look at the difference of output and no output. If you just call recursive in, it will not output anything during execution here. Because we simply do the return in recursive, we are unlikely to directly output in the recursive. So in this case, we will output in the main programming code area so that we can get the output result we want. That is, output the result of 120. Let's submit it and see. Here, it will pass the test. Let's try and see how to use recursive to solve this problem. Let us take a look at the function of the greatest common divisor in the recursive unit and how to solve this problem. So the problem here hopes that everyone uses the Euclidean algorithm and the concept of recursive to design the function of the greatest common divisor. For the user to input two numbers after the function is called to execute. Output the greatest common divisor of these two numbers. Please note that if the value of two numbers is less than or equal to 0, remember to see whether it will have any problem. Here, we first built the C++ format. Include IOStream using namespace stand. And then in the programming code, return 0. In the area of main programming code, we need to input two numbers and then call the function of the greatest common divisor. Because it is performed by recursive, we will write the output in the main programming code. Then we will first create two variables for the user to input. CNN, then CNM, two numbers. Then we can do cout. We are going to calculate the result of that function of the greatest common divisor. For the greatest common divisor, we usually call it GCD, which is the English abbreviation of greatest common divisor. Enter these two numbers. So next, we are going to write the function of GCD, the greatest common divisor, and how to write its recursive. Then we create two variables here. Put two parameters in, both are integer parameters. After creating and putting in, we need to think about how to use recursive and use Euclidean algorithm. You may not be familiar with what Euclidean algorithm is. Actually, the most important concept of Euclidean algorithm is that it is obtained through the principle of division, that our dividend and divisor, its greatest common divisor, will actually be. Here, A is the dividend, and then B is the divisor. The greatest common divisor between them actually is the same as B and the remainder of A and B. It is the result derived from the principle of division. If you're interested, you can check it out. So when we are processing it, we are actually constantly replacing the three things of divisor, dividend, and remainder. I'll give you an example. Let me think like 24 and which one should it be with? 24 and 16. If 24 and 16 are going to calculate the greatest common divisor, we may not know how to calculate the GCD of 24 and 16. But we know it is related to the remainder. So when we calculate the greatest common divisor of 24 and 16, we can regard it as 16, the greatest common divisor of the 16. The remainder of 24 is divided by 16. That is regarded as 16. And then what is the result after being divided? After being divided, the remainder should be 8. 16 and 8, its greatest common divisor. Then, if you still don't know how to calculate 16 and 8, then we will continue to break it down. Regard it as 8 and 16, and 8 in its case. That is the greatest common divisor of 8 and 0. At this time, I found that my remainder is 0, which means that actually the 8 earlier will be my greatest common divisor. So we can know the greatest common divisor between 16 and 8, and the greatest common divisor between 24 and 16 will be 8. This is the result after the execution of the so-called Euclidean algorithm. It uses the greatest common divisor of the dividend and the divisor, which is actually equal to the greatest common divisor of the divisor, and the remainder to process with this condition. Is that okay? The stop condition is here when this number is equal to 0. It is time for us to stop. Then the number before it is our greatest common divisor. So, if we want to write it as programming code, we will end when the latter number is equal to 0, and then the latter number will be b. If b equals 0, we will end at this time. That is, we will return the previous number, which is our greatest common divisor, and return a. What if it is not the case? If b has not yet been equal to 0, we will replace the dividend and the divisor with the divisor and the remainder before calling GCD. So the dividend, the part of the dividend becomes the divisor, and the part of the divisor becomes the remainder. In this way, let's execute it and see. Let's just randomly input it and see the earlier 24 and 16. The result was 8. Then maybe 54 with 26. And the result is 2. Then another one, 1, 2, 3, 4, and 5, 4, 3. The result is 1. They are relatively prime. This is the way of calculating the greatest common divisor we want. Everyone can try it out. Next, let us take a look at the problem of Pascal's triangle in this unit of recursive. Please design the Pascal's triangle with the concept of recursive. For the user to input the row value in to be displayed, after the function is called to execute, output the in rows of Pascal's triangle. Pay attention to what situation will happen when n is less than or equal to 0 and how to avoid them. For the second one, if you are in a later stage, you can try to deal with it to see its arrangement position. Here, let's do some normal output first to give it a try. First, we write the format. Include IOStream using namespace stand. And then our main programming code area. Return 0. What are we going to do next? First, we are going to build a variable for the user to input. In the same way, when it is less than or equal to 0, if you want the user to input repeatedly, you can let the user input this variable repeatedly. Then, if you want the user to have some prompt texts, you can write them, but you should pay attention to the part with the data test. Do not display the prompt text at will. Then it doesn't matter if there's no data test here, just enter it at will. Then to judge our in, its condition, if it is less than or equal to 0, you can output its program if there is an error, factorial number input error. Then it depends on whether you want to allow users to re-input. If you want, you can use the method we learned earlier, use goTo. Or you can also use the way of while to process it. Both are fine, as mentioned many times before. So you can think about what kind of repetitive execution method you want to use. Then, for the first line row and column can be input. Next, we can think about what we want to output. In this case, our output can be which column can be displayed in the end. What will be the condition of that column? So what can be displayed will look like this. Similar to this form, and output like this. That's why we can display row and column at the beginning. If the output is like this, we just need a for loop. For I equals 0, I less than n, I plus plus. Then in this for loop, we can first output it to the end. This foremost factorial number, 1, 2, 3, 4, 5, so we can output I plus 1 first. Then you can also process it directly in the loop. Don't change line after outputting I plus 1. We can do some simple processing for the space. If I plus 1 is greater than or equal to 10, that is when it is a 2-digit number. We can output just one space. Simply process it, just output one space. Then, if it is not greater than or equal to 10, that it is between 1 and 9, then we output 2 spaces, 2. Here is 1 space, here are 2 spaces. Then you may ask, what if it is greater than or equal to 100? Because of this Pascal's triangle, you actually input a bigger number. It will not look good after executing it, and it may not even run. So we will maybe output only a dozen or 20. Then let's process it a little bit. Next, there's another loop. We want to output what's in the loop. We were processing the first row just now, the first 1, 2, 3, 4, 5, and then we want to output the 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1 here. We just use another loop here. We use j. J less than or equal to I. If it's 1, Then there is 1. If it's 2, there are 2. If it's 3, there are 3. The fourth factorial has 4. The fifth factorial has 5, so less than or equal to I. Then let's allow j to do plus plus. What are we going to do next? We are going to output the real Pascal's values. For the part, we use a Pascal's function and put in the place with its number of column and the number of data so that we can capture what it actually is. Then every one, let it have a space to process. Then outside the for loop, we can let it change line. Then in the case of for only having one line, it does not matter if you don't use these parentheses. In the case of one line, it can be executed directly. Next, we're going to write this Pascal's function. Then use PAS here, which is the first 3 letters of Pascal. So we need to have 2 variables in it to represent which position it is in and which one on which factorial. Then the n represents 1, 2, 3, 4, 5, this one which factorial. Then the k will be here, 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. These data its position. So in Pascal, we can see that the first one is all 1, and the last one is also 1. That is to say, when k is at the forefront, when it is equal to 0, or when k is the last. That is, when it is equal to n, it must be 1 in both cases. When it is 0 at the forefront, when it is k at the end, when it is n, it always is 1 in both cases. In this case, we can know that in these 2 cases it will be 1, and we will return 1 to it. What about other cases? We just want to look at other cases like 3, it will be 1 plus 2. 6, it will be 3 plus 3. 4, it will be 1 plus 3. So it is to add the number on the upper left and directly above. Then it will get its own number. Then we're going to use the concept of upper left and directly above. Then n refers to the above, so n uses minus 1. That is to go back to upper factorial. If n is 5, I will go back to the fourth factorial. If n is 3, I will go back to the second factorial. So n is always minus 1. For the part of k, we use k minus 1 at the upper left, and for the directly above, we can use k only. So the number at the upper left plus the number directly above will be the number I want. Then run and run all the way until if it reaches the boundary, it will be 1. Then let's execute it and see what the result will be. We first output 5 factorial. It can be seen here. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Then let's output 10 factorial. Then as you can see that when it is 10, we only have 1 space. For the purpose of this line of 1, it can be displayed in the same place. Then we input 15. You can find that 15 is very big, so we're unlikely to input 3 digits. Just 15 is already so long. So we will only process the parts of the units digit and the tens digit. and output 2 spaces for the units digit and 1 space for the tens digit. This will be our Pascal's triangle. Give it a try. If you're interested, you can also challenge it and output it in a situation that is more like a triangle instead of a right-angle triangle. Those who are interested can challenge it. Then we can first build a basic version and then see if there is a more advanced version to be built. Let's give it a try.